Hello, good morning. Can you hear me now? Okay, thank you. So it's going to be an interesting session, and as we know, the entire world is deeply concerned about climate change. Uh, promoting, you know, promoting green energy has become, the ambition for each and every country. Either big, small, or have already set renewable energy targets, net zero targets. While these targets demonstrate commitment to reduce carbon emissions, there is a critical oversight, at least in many of the countries, that upgradation of transmission or distribution network to accommodate the integration of renewables are never been accounted for. That has been always been a issue. Actually, the policymakers always set targets for ambitious targets, but they expect the power system functions like smartphones. They want to take photographs, videos, and everything. Uh, Similar to photographs, videos, and everything in a smartphone. They function the older systems which were installed decades ago to function like smart grids without investment. So there's a serious concern. So, and we really have a fascinating lineup of speakers here from major utilities, distribution companies, and those who are experienced in energy transition, and also technology providers. So I would, request the speakers to, finish the presentation within 8 to 9 minutes, so that we have time for deeper discussion later. Without delaying further, I would request Mr. John Cotton, Senior Program Manager, Energy Transition Partnership, to present support to upgrade the Java Madurai Bali Control Center, Jamali Control Center. Thank you.
Okay, good morning. Thanks for joining this morning. It's a good turnout for Thursday morning. So my name is John Cotton. I'm the Senior Program Manager of the Energy Transition Partnership. The Energy Transition Partnership, just for a bit of background information, is a multi-donor platform that was set up by governments and philanthropies. So the governments of UK, France, Germany, Canada, Australia, and several philanthropies came together and created a fund. Our job as a secretariat is to manage this fund. We do this by working with the governments of Vietnam, Indonesia, and Philippines and supporting them with their energy transition. We do this by looking at four key areas. So the first one is aligning policies with climate commitments. So we've seen strong climate commitments since we started in 2020. There's been massive climate commitments across the region. So COP26 saw two of the three countries with net zero announcements. So our job is to support the governments in designing the policies that align in achieving these targets. The second is de-risking energy efficiency and renewable energy investments. So unlocking the financial flows. The idea here is once we have the policy, regulatory, legal environment in place to facilitate an environment for renewable energy and energy efficiency, we then need to unlock the finance. When we have the finance in place, we come to number three, which is what we're talking about today, which is the grid infrastructure. Actually, the order of this could probably be presented differently in that smart grids or at least a sufficient grid infrastructure are absolutely critical for 1 and 2 to be of any use. There will be no investments in renewable energy unless the grids are ready to absorb. I think we saw in Vietnam 2018's boom in solar. The policy suites were fantastic in that they encouraged huge investment into solar. But today we're still facing curtailment from the overproduction from solar facilities. So working on the grid today is an absolute imperative. It's going to take time. Grid investments and grid infrastructure upgrades don't move quickly. It's huge infrastructure projects. So the sooner a country moves into these areas, the better it is. Across the countries where we work, so Vietnam, Indonesia, Philippines, but similar globally, there are many, many different pathways to achieve net zero, to decarbonize the energy sector. But there are some kind of global truths that all countries will pursue. One of these is the grid upgrades. No matter what pathway the country is taking, whether they're looking at using hydrogen, or they're considering co-firing with ammonia, or whatever they're looking at, grid upgrades are essential. And grid upgrades and future-proofing the grid is a critical area, which is why ETP, with our limited funding, focus on this area. We really see the importance of strengthening the grid for energy security reasons. And the last area, also I think very pertinent to this discussion, is knowledge, awareness, and capacity building. But building the capacities of utilities in particular to handle the new technologies. Um, I'd say this goes a lot beyond the capacity building. We're also talking about the opportunities in innovation. Grids globally. So I'm from the UK. I listen to a lot of podcasts and read a lot about what the National Grid are doing in the UK. It's created a huge sector, an opportunity for innovators to fix problems as they arise. And there are lots of problems by trying to integrate more renewable energies into the grid. And each country will develop its own innovative solutions. I think the next speaker after me actually has some good innovation technologies which will be explored. Um, in addition to innovation on air, B is a technology transfer from other countries. We need to create the right platforms and environments so that countries which have found solutions to problems can bring them to other countries and speed this up. As I look, I say I'm already halfway through my presentation. There's a massive clock down here. It's quite imposing. It kind of reminds me of the climate countdown clock where I think we're at 10 minutes to midnight. Uh, Anyway, I'm at 4 minutes, so I'll keep going. So I'm going to go quickly. I'm going to skip a little bit. But so basically, power grids kind of unanimously agreed to be an incredible feat of engineering. There's some statistics here. I like the top one here. There are complex machines in existence with millions of components making up the supply chain, and they're open ceiling factories exposed to all kinds of disturbances, climatic, human, vegetation, animals. So we have this incredible network of energy transmission, distribution outside in the open. And in 2001, the American Academy of Engineering recognized that the electrical grid was the greatest engineering achievement of the 20th century. This is incredible, the greatest engineering achievement of the 20th century. Now, at the heart of these electrical systems, I'm going to have to hurry up. At the heart of these electrical systems is a control center. So it's similar, the control centers are basically the main role is to capture the, I'm going to skip. So capture the flow of electricity into the grid and manage its distribution, keeping a balance. So every time you turn on your lights or the air conditioning, it works. It's really incredible how this works. So like an air traffic control system, very similar to air traffic control, in that the control center is controlling the planes coming in, landing and taking off without any disturbances. And we have energy security. Now, bringing variable renewable energy into grid is like telling the air traffic controller that when it's sunny, you're going to have 20 times more planes coming in. And as soon as the sun goes behind a cloud, you're going to have no planes coming in. But we still need the planes to be landing. And when it's windy, and you get the idea, this is the challenge variable renewable energy is posing to control centers. Traditionally, on the left, we have large power plant and we have a city. The large power plant generates power, the city consumes it, and the control center's job is still incredibly difficult, don't get me wrong here, but it's to manage the balance of that flow. With modern systems coming in with variable renewable energy, with battery energy storage systems, we have an incredibly complex network of generators and loads and off-takers which need to be balanced. The control center is at the heart of this. Without control center technology, this is basically impossible. It can't be done. So ETP, we worked with PLN in Indonesia. They have currently a control center which is antiquated and not capable of integrating variable renewable energy. Um, ETP, ETP with our partners, I'll skip a little bit, with our partners, um, conducted the detailed design of the SCADA EMS system and architectural designs for the building, of which ADB has then gone on to fund. This is now being tendered and will be constructed this year. This means that the Java Bali Control Center in Indonesia will then be constructed and allow Indonesia to start building out its variable renewable energy. When we started working in 2020, this was given as the single most important impediment to why Indonesia cannot progress and integrate more variable renewable energy into the grid. It's not the only impediment, and it's not entirely true that they couldn't have higher levels of variable renewable energy, but it wasn't future-proofed. So the work that we've done led by PLN has now allowed this to open up. I'm down to 45 seconds. This is a design, slide sets online. You can take a look. I was going to explain what SCADA EMSs are, but SCADA and EMS basically is SCADA is the tools which allow you to acquire data and store the data, analyze the data. And the EMS, the electrical management system, are the tools which manage this data and allow you to basically consider things like weather planning, what's going to happen when the cloud covers this area, how are we going to ramp up different energy sources from different locations to mitigate this, when are we going to start filling up our pump storage hydro, and when are we going to release it. So with AI now coming in, these EMSs are incredibly, incredibly powerful and will allow us to move forward much easier to a low carbon energy sector. Okay, so in short, PLN, with its control center development, is paving the road to effectively support all unforeseen challenges. What I'll say about PLN and this project, just to summarize, when we set off on this project, it was an idea to upgrade the control center to increase energy security and to incorporate variable renewable energies and reduce greenhouse gas emissions. What we saw, PLN want to use this project as a landmark for themselves. While we were going through the architectural designs, there was all sorts of ideas to change it from 3-story to 20-story, to put on helicopter pads, to do all sorts with it, because they wanted it to be a symbol of the energy transition. They wanted it to be a symbol of Indonesia embracing the energy transition. And this is really, really reassuring. This is really exciting, actually. So we partner with PLN, and we believe PLN are the key to unlock the energy transition in Indonesia. And working in partnership with them, we're very excited to see Indonesia achieve its very high level VRE integration goals and its decarbonation targets. Okay, my time is up. Thank you very much.
Thank you very much, John. I know that you have a very good presentation, a detailed presentation, but probably later on we will allow you to explain a bit more during the Q&A session. And probably I like the idea of you mentioned that power grids are the most complex devices in the power system. I do agree. And the grid engineers, everybody expect them to know all the renewable energy to be integrated. They expect to know wind, solar, biomass, everything. But you have specific renewable energy experts for each and every category. But the grid experts are expected to know everything. So that's the whole trend. So without delaying much, probably this is going to be another interesting presentation. I would like to invite Nicholas Ottersberg, Senior Business Development Manager, Nuvendra, using innovative technologies and business models to fight the use of SF6, the world's strongest GHG in electrical infrastructure. Thank you.
Good. Good morning, everyone. Is it working? Hello? Great. Yeah, good morning, everyone. Thank you so much for having me. ADB, thanks so much for the invite. So yeah, my name's Nicholas, and I am here representing New Ventura, which is a German SME based in Berlin. And what we do is we develop environmentally friendly switchgear technologies, which avoid the use of SF6 or sulfur hexafluoride. Before I dive into the presentation, may I quickly ask who actually knows what switchgear are? Can you quickly just raise your hand? Oh, wow. Okay, so I'm in a room full of experts. I might as well just go. No, even though I am in a room full of experts, I hope that this presentation will still be interesting and you might learn something. So the idea is that I'm going to quickly explain the problem that is the use of SF6 in switchgear, and then I will deep dive a little bit into how, through a combination of new technologies and also innovative business models, we can help address the problem. Good. So for the minority of people here that don't know what switchgear are, they're essentially grid scale light switches. So they are essential components found throughout electrical infrastructure. And their job is to turn off and on different sections of the grid. So wherever you have power requirements, you will have switchgear. Now, unfortunately, switchgear are also the main use case for the world's most potent greenhouse gas. And as you may have guessed, that gas is called sulfur hexafluoride, or SF6. Now, when it comes to climate change, SF6 is really bad news. So it has a global warming potential of 23,500, which means that 1 kilogram of SF6 is equivalent to 23,500 kilograms of CO2, 23,500. In terms of global emissions, they're around 8,000 to 10,000 tons annually, and that's equivalent to the yearly CO2 emissions produced by around 100 million cars, 100 million. And just to make matters even worse, I'm not sure if you can see it behind the table, but in a business as usual scenario, the use of SF6 is actually projected to increase by 75% by 2030 from 2019 levels. And the reason for that essentially is the rollout of power systems around the world, and that's linked to the expansion of renewable energy sources, grid modernization, electrification, all of which will require a lot of switchgear. Right, so because of this environmental footprint, regulators around the world are starting to focus more and more on the use of SF6 in switchgear. Notable examples of this are the European Union, which have announced that they're going to start phasing out SF6 starting in 2026 from switchgear. Also in the United States, California have announced that they're going to start phasing out SF6 starting next year, 2025. And as a matter of fact, we're already seeing other US states basically copying and pasting the Californian regulation. So we think that the whole country is basically going to become SF6 free. And very notably as well, China is moving at lightning speed towards SF6 free power systems. So just to give you an idea, just 2 years ago, only 5% of switchgear tenders in China requested SF6 free products. Today, it's 90% of switchgear tenders are asking for SF6 free products. So this is an extremely fast turnaround and just goes to show what is technically possible when there's political will. Great, so because of this regulatory push towards SF6 free power systems, of course we need alternatives to these SF6 free SF6 products. And New Ventura, my company, develops such alternatives. So we develop switchgear which replace SF6 with something called dry air, a completely natural and environmentally friendly insulating medium. And by dry air, what I mean is essentially just what it says on the tin. So normal breathable air, but with the moisture removed. And we've achieved this whilst maintaining the characteristics which make the SF6 switchgear attractive around the world. And that's essentially compact physical dimensions and also high reliability. And our product is type tested, so it's gone through all the normal certification process, and we've had references in grids since 2021. So New Ventura was the first mover in the direction towards SF6 free switchgear that use dry air as the insulating medium, but we're no longer alone. So we're actually part of an alliance of companies that have been active at the European level advocating for the replacement of SF6 in switchgear. And the other alliance members you're probably more familiar with, and they include Mitsubishi, Schneider Electric, Siemens Energy, Siemens, and Toshiba. And also more recently, Ormazabal in Spain and also ABB in Switzerland have also announced that they're developing dry air switchgear technologies. So as an industry, we see a clear direction of travel towards replacing SF6 with natural gases such as dry air. So in New Ventura's mission towards encouraging the replacement of SF6 with natural gases, our production, we've developed a global footprint. So our production takes place between India and Germany, and we've delivered projects in North America, New Zealand, and Europe. And we're developing partnerships in Europe, Turkey, Colombia, Bangladesh, Canada, South Africa, and also New Zealand. But to have a truly global impact, we need to have an even broader reach. And this is where our business model comes into play. So we don't want to conquer, we want to partner. So we want to enable local companies around the world, including in Asia, to be able to offer these SF6-free products to their own customers, and this can be done in a couple of different ways. So one, we can provide basically naked panels, which we call primary panels, and then the partner, which would be a local engineering company, an EPC company, or a panel builder, they would customize the product to their customers' needs, and then also do the final installation at the project site. Or if the partner has a stronger manufacturing capabilities, they can basically buy a core module from us, which is essentially the heart of the technology, and then do the installation themselves. I see I only have 50 seconds left. So the benefits of this model is that everyone does what they're good at. We do the products, and our partners build on the relationships with our customers. So this is an example from Austria, where we worked with a local engineering company, and a product was delivered for a local utility, Energienetze Steiermark. So in summary, I hope a couple of key takeaways from this presentation is that for the energy transition to be truly sustainable, grid components and grid infrastructure also needs to be sustainable. Furthermore, it's now clear that the industry as well as major markets are moving towards SF6-free switchgear. Now the question is whether the rest of the world will be proactive and basically begin preparing for this SF6-free future, or be reactive and be disrupted in the future by supply chain issues and capacity constraints. Of course, we hope that it's the former, and if it is, we'd be happy to have a conversation. Thank you very much, and I look forward to any questions.
And thank you very much, Nicholas, for the interesting presentation. I assure you that you present to the right audience here, because many of them are from the utility head, and they can make some policy decision if they really want to move. So probably you may raise, you can talk to them later. So that's one thing I want to mention. And for everyone's information, SF6 is also one of the dense gas. So it will be there at the bottom of the gas chamber every time the SF6. So it's also poisonous. So that's a couple of things I wanted to add. Without delaying much, probably I will now invite Ms. Havalusa, Assistant Director, Ministry of Climate Change, Environment and Energy, to present us on the grid challenges faced in microgrids in the Maldives. Ms. Hava, please. Thank you.
Good morning, everyone. My name is Liuza, and I'm representing Ministry of Climate Change, Environment and Energy Department of the Ministry, which is the major policy-making body of the energy sector of Maldives. And in my presentation, I will focus on the technical challenges Maldives is experiencing in integrating large-scale renewables. In particular, I will focus on two particular contexts, that is Outer Island and the Greater Malay area, which is the capital. To begin with, I'll just give a brief introduction of Maldives and our power sector to give a better idea of our unique context. Maldives is one of the most geographically dispersed country in the world. We have 1,192 islands, and out of this, 187 is inhabited, and we have a population of around 500,000, and we have 168 tourist resort, that is like one island is one resort, and they operate their own power grids. So our land area is very limited, and it is 99% is ocean, and our islands are average 1.5 meter above sea level, making us very vulnerable to impacts of climate change. And for our power sector, we are entirely dependent on imported fossil fuel, which we spend around 30.5% of our GDP for oil imports. And for installed capacity, we have around 614 megawatt, out of which we for renewable contribute to roughly around 65 megawatt. And as for in last COP28 summit, our president has pledged to increase our renewable energy to 33% of our electricity needs by 33% within the next 5 years. And also we still have our target to achieve net zero by 2030. So this transition requires a relevant investment in grid assets for smoother integration of renewables. So as for the grid challenges in outer islands, we are talking about many islands dispersed, and we cannot connect with a single grid. In this context, traditionally, the outer islands grid infrastructure has suffered from underinvestment. So the grids are basically laid initially to cater lesser demands. So currently, the grids are unable to cater for the increased demand. So the infrastructure, grid infrastructure, lack the robustness, resourcefulness, and resilience to varying degree. So with the assistance of POIST project and ASSURE project funded by Asian Development Bank, optimal distribution expansion planning is being implemented. Under this intervention, the grids have been modernized. And further, the grid is equipped with battery energy storage system that allows smooth integration of current and future PV power plants, providing stability to the island mini grids. Also, it is supported with the generation assets are operated under the energy management system, as you can see from picture 3. And this infrastructure should also be designed to be climate resilient, as Maldives is very vulnerable to impacts of climate change. And also due to the limitation of existing grid for economic development activities like guest house businesses, ice making, and so this intervention will provide more capacity for in the grid. So in short, we need a technological solution for we are talking about we need for every island. With grid modernization, we need a battery energy storage system and also energy management system, which is actually a costly solution. In the context of Male region, this is where the 1/3 of population resides. So in this context, the interconnection is technically and financially feasible in this region. Currently, Male and Hulumale is connected with an interconnection system of 132 kV transmission line and by 11 kV substation. So in the future, the power system of Greater Male is conceptualized to serve 6 islands, and also it is proposed to extend this transmission line up to Tilafushi and connecting to islands of Vilingili and Gulifal on the way. So this expansion of transmission system in the Greater Male will support utility scale investments. Yeah, that's the end of my presentation. Thank you.
thank you very much, Ms. Lusa, for explaining the difficulties faced by the microgrids, and also mentioning on how the Ministry of Climate Change, Environment, and Energy is trying to mitigate these issues. And also, I think we missed some beautiful photos from the Maldives. So that is missing in the slides. Probably next time. So with this, probably I would request now Mr. Tosakon Opitakon, Head of Transmission System Security Planning Session, Electricity Generation Authority of Thailand, to present a case study on transmission upgrade by using ACCC reconductoring approach for connecting with one of the power plant project, which is Hinkom Power Plant. May I request Mr. Tosakun, please.
Hello. Good morning, everyone. My name is Tausakul Obitakon, Head of Transmission System Security Planning Section from EGAT, Thailand. Today, we will explore the successful project of EGAT to connect the new 1,400 megawatt from Yinkong Power Plant to connect to our grid. Let's start. Thailand is a growing economic demand. The Hinkong Power Plant project aligns with the power development plan to ensure the power system security in long term. The new plant is a double capacity of the retail plant. The retail plant is named the Chico. This need to upgrade the existing transmission line. The existing line is a 230 kV from Ratchaburi to substation connect to the power plant. Total distance about 7 kilometers. The conductor size is 2 bundle of 1272 MCM SCSR. For emergency case, for N-1, it cannot transfer a double capacity to the grid. So we need to do something to solve this problem. This slide shows how to solve the problem. For first option, is a traditional grid expansion, increasing transmission line capacity by dismantling the old line before building entirely a new line. This process is rarely expensive and impact on the community. For second option is reconductoring, by replacing conductor on existing tower with higher capacity. This way minimize the risk of any uncertainty in the permission process, minimize construction cost and lower time compared to building a new line. This slide provides more detail about the problem on traditional grid expansion. For this way, although the transmission line construction is on the existing right of way, but EGAT need to remove the existing tower and replace with a new larger one, or left or right side if you see it on the screen. For traditional grid expansion, we need at least nearly 7,000 square meters of land to build a new 21 tower foundation. So reconductoring approach can minimize social and environmental impact. Additionally, it can save about 30 million Thai baht in land compensate for foundation installation along the line route. This slide shows process and timeline between traditional grid expansion, the blue one, and reconductoring, the yellow one. If it can choose the blue way by building a completely new line, it can must compensate the community for the right of way once again, because it's necessary to remove the existing tower and install the new one, as I showed on previous slide. So this procedure is managed by Energy Regulatory Committee of Thailand, or ERC. It takes a long time and depends on the community area. Furthermore, the construction process of building a new transmission line takes longer than reconductoring. Finally, please consider the power plant schedule energizing date, or SCD, on June 2033. Reconductoring is only the possible way. When upgrade the transmission line with a high temperature, low sag conductor, several options exist. But for traditional in-wire conductor, a low coefficient of thermal expansion, ECAT has been utilizing this kind of conductor for a long time. But the primary issue is a higher transmission line loss than ACSR conductor due to a higher resistance, right? Another one is a carbon fiber composite core or CFCC, which had a better strength, lower sag, and less weight, resulting in a reduced resistance and increased capacity. But ECAT have not utilizing this type of conductor before. So, which kind of conductor have a more benefit in terms of power system security, efficiency, and environmental sustainability? This slide shows the technical comparison between in-wire and CFCC in terms of power system security. For in-wire conductor, maximum conductor size on existing tower is a 2 bundle of 456 square millimeter, and maximum continuous ampacity is about nearly 3,800 ampere. Due to the CFCC lighter than in-wire, it can use a bigger size, and with maximum continuous ampacity is about 4,300 ampere. In case of an emergency, which one line trip, as you see on the screen, another circuit shall carry a current greater than 4,100 ampere to accommodate the power from the power plant to the grid. In terms of efficiency, because in-wire conductor had a higher electrical resistance than CFCC, right? Therefore, the in-wire conductor transmission line loss will be higher than that of the CFCC conductor. The simulation software was used to compute the megawatt loss displayed on the screen. Moreover, transmission line loss is used to calculate CO2 emission. As a result, the CO2 emission from CFCC line loss are lower than in-wire. This slide shows the least cost analysis between CFCC and in-wire conductor. We compare the capital cost, maintenance cost, cost of transmission loss, and CO2 emission cost. By the way, for the capital cost and maintenance cost, we assume both types of cost are the same. So, transmission loss and CO2 emission cost affect the outcome of net present value cost analysis. The chart on the right side, show the net present value of total life cycle cost for 25 years. According to the chart, the CFCC option has a lower overall cost. Therefore, the CFCC option is more economical than in-wire alternative. For conclusion, lesson learned and way forward. Reconductoring, a process of replacing existing conductor with a higher capacity was chosen over building a new line for this project. This save time, save cost and permission process, and minimize the environmental and social impact. For CFCC technology can reduce the transmission line loss, resulting in significant lower carbon footprint compared to in-wire conductor. And finally, according to ECAT, carbon neutrality by 2050, it had a potential for duplicate this successful model across other projects in ECAT grid expansion plan in the future. Thank you.
That's an interesting presentation, and probably right of way. So everybody is struggling with, that's even ADB projects also struggling with actually, So right of way is a key issue, and wherever possible, reconductor with, upgrades is the best option. And with this, probably I will now invite the next presenter, Mr. Debashi Sarkar, Managing Director, Tripura State Electricity Corporation Limited, to share his experience on powering up the state of Tripura on the journey towards the grid stability and smart energy. Thank you. Mr. Debashish.
Good morning. Myself, Debashish Sarkar, Managing Director of Tripura State Electricity. Tripura is almost an unknown location in India. Is a northeast, one of the smallest state in India in the northeast. Uh, Before starting the presentation, I'm just giving a brief overview of the Tripura. What is the basic benefits of the Tripura? Is a land of permanent springs. It is the largest bamboo production hub in India. It is a home of 21 species of bamboo. It is also the second largest rubber producer in the country after Kerala. It has got 85 acres of land. It is also the fifth largest tea producing state. It has got 58 tea gardens. It has got a unique natural cultural mix in the handicraft area. There are 3 Bengali tribals and Manipuri characters are available in Tripura, and they have their own unique cane and bamboo handicrafts are available there. Because of its favorable climatic condition of the cultivations, food and horticultural crops are very much tasty and widely accepted in all over the world. Even the queen pineapple is accepted all over the world and is exported everywhere. It is also the treasure of the natural medicines. It has got around 226 medicinal plants, different species of trees and other things. Now I come to the basic power sector scenario. If we see our 2023-2024 power scenario, our energy input is in the tune of 1625 million unit. Out of these, we have built around 1235 million unit. So billing efficiency is relatively lower. 76% is the billing efficiency, but collection efficiency has improved substantially, and our overall AT&C loss is 22%. And that's good. We have reduced our AT&C loss from 26% to 22% in a year. So we are striving in the positive direction. As far as the consumer's profile is concerned, that is a very bad mix of consumers available in Tripura. We have got around 10 lakhs total consumers. Out of these, 8.5 lakhs are domestic consumers. And out of these 8.5 lakhs domestic consumers, 7.5 lakhs consumer is having a consumption less than 100 units. So basically, there is no portion of cross-subsidizing the lower-based consumers with the high-end consumers. Our commercial consumer is only 73,000, and you will see in the mix, industrial is only 6.4%, is only 1% of the total million unit consumption. Our overall peak demand is 490 megawatt, and we have got a mixture of our own gas-based power plant, hydro power plant, plus we have got a long-term PPA with the different organizations, central PPA. For this, we are not a power shortage state, we are more or less a power surplus state. Now, if we go to what are the challenges we are facing? First challenges we are facing is 70% of the Tripura area is covered by the forest. It's a highly thunderstorm prone area and lightning. So, and there was a soil gripping is very poor, resulting the constant uprooting of the trees and tree branches and affecting our overhead network and subsequently the reliability of the supply. Our infrastructure is an age-old infrastructures. Our distribution transformer, power transformers needs immediate replacement. Even our circuit breakers are there. Still there is MOCBs are there. So this is the age-old infrastructures needs to be replaced in a phased manner. And as I pointed out in my earlier slides, our billing efficiency is eating our performance. Poor billing efficiency is increasing to the elevated AT&C losses, and our safety figure is also affected because of the constant tripping and breakdown of our over aging networks. Now, we are now extremely expressed our gratitude to Asian Development Fund. They come up with a funding of 220 million for the improvement of the Tripura power distribution strengthening and generation efficiency improvement, and which is ultimate largest approved project of ADB in the states. What we are doing it with the ADB's help, we are improving the technology. We have got a gas-based power plant, which is an open cycle power plant. We are converting one of our gas-based open cycle power plant by a combined gas cycle power plant by utilizing the same gas, because it will improve the operational efficiency of the plant, it will reduce the carbon emissions, and ultimately it will reduce the generation cost of the our overall power purchase cost. So this is a triple benefit by improving the efficiency of the gas-based power plant. We are also ensuring the energy security. We are preparing a renewable and energy and distribution sector roadmap to support the renewable energy development and have a proper blending with the conventional energy, keeping in mind the net zero concept of our honorable prime ministers. We have also planned for the modernization of our both distributions, transmissions, and generation network. We are going to introduce our distribution system automations, metering replacement by smart meters, and other ring-main features to improve the supply reliability. To sustain the business, financial sustainability is the most important and critical things. Our ultimate focus is to assure the financial sustainability of the business so that we can be self-reliant and we can run the business by our own strength without the help of the government. That is the ultimate motto, because Tripura Power, though it is a government control organization, it is a corporation, and we are planning to run it as a own without the support of the government. That is the ultimate motto. What are the salient features of our project? We are converting our existing Agartala city from the entire overhead network to underground network in a phased manner. Right now, we are targeting 130 kV, 33 kV, and up to 11 kV level. Entire network should be underground. And not only underground, we are planning to make it ring-main features by introducing the RMUs in the system so that it will ultimately increase the supply reliability and redundancy, and it will in turn improve the safety of the pictures. We have introduced fault passage indicators and auto recloser sectionalizer as a part of the distribution system automations. We have got a still long overhead lines with number of branches. Huge number of our overhead lines is around 70 kilometers, 100 kilometers long, around 5-6 branches. And any case of any fault develop in any of the overhead network, itself is a Herculean task to identify the fault, and ultimately it will increase the time interruption and the consumer's resentment. To avoid these things, we are planning to introduce the auto recloser and sectionalizer, which will ultimately improve our restoration time and consumer satisfaction. That is the basic target. We have introduced number of 33 kV bays and also replaced the aging switch gears, and we are consciously replacing some of the SF6 switch gear by vacuum switch gears, keeping in mind this polluting effect of the SF6. We have also introduced number of smart meters. Now, in the ADB project, we are planning to replace all our postpaid meters by smart meters through different projects. ADB's project is one of those projects where we are going to install 1.5 lakh smart meters covering the Agartala city, which will ultimately improve my billing efficiency. And also, we are planning to commission one NABL accredited transformer testing laboratory to have their own testing features, and it can be utilized also for the commercial purpose. We are also planning to introduce the HVDS network in the pilfer-prone zone to reduce the pilferage concept and improve the AT&C losses. We have also have intervention of the other project going on in our systems. One World Bank project is going on, which is looking after our transmission system upgradation. Because to make the entire system reliable, it needs to be reliable right from the generation, transmissions, distributions. All three chains should act concurrently to make the system reliable. We are planning to make the transmission system N-2 redundancies doing. For this, we are introducing so many number of EHB substations, EHB lines, and ultimately the entire 130 kV network we are planning to introduce ring main, so improve the supply reliability. And in also, we have got an existing 66 kV overhead network, which is incurring the loss in the system. We are going to upgrade the 66 kV voltage level to 130 kV level, which will again improve the voltage profile as well as reduce the system loss. We have also central intervention of RDSS scheme, which is taking care for the entire India. 3 lakh crores funding is coming from the central government, where basic target is to reduction with the loss, and every state has their own target of trajectory of AT&C losses. For us, 19% is the AT&C loss is the target until 2026. We are moving towards that. Here we are converting our bare LT conductors by LT AV cable, because we are witnessing a huge amount of pilferage. Instead of installing the smart meters or prepaid meters, consumers have a tendency to pilfer from the overhead lines itself, if it is a bare conductors. So we want to avoid these things by converting the bare conductor by LT-AV cables, so that the pilferage can be reduced, and ultimately we can improve the loss figures. We are also planning to introduce almost 4.5 lakh smart meters through this RDSS scheme. So around 9 lakhs consumers through this RDSS and ADB scheme, we are planning to cover the entire consumer base from conventional postpaid meters to prepaid meters. We have also our own revenue management system, which will be integrated with the ERP systems and IoT-OT-based system to have the more transparency in the data. We are also planning to introduce the online transformer monitoring is a part of the conditional monitoring, which will reduce our transformer breakdown. And as I have already told, I have introduced the HVDS networks. What is the ultimate outcome? It is improve the reliability of the supply. It will reduce the system losses. It will improve the operational efficiency and the financial stability. In futures, we are planning to introduce the conventional meters, SCADA implementations, conversion from the AIS to GIS substation, conversion from AIS to GIS substations, and solar energy, renewable energy introduction to improve the overall efficiency of our system. Thank you.
That's a very detailed presentation on states, all plan towards not only just attacking generation, but also distribution, but also transmission. So overlooking future renewable energy plants and also reducing the loss reduction, both technical and commercial losses, which is very important. And we noted your states, difficulty with the consumer mix, which is most of the consumers are consuming and in the subsidized class, we're in the lower tariff slab, and you have a daunting task to supply these in the rural areas. And very, very enriching presentation, sir. And with this, the next one we will ask Mr. Dirgayu Kumar Shestra, Deputy Managing Director, Nepal Electricity Authority, to present enhancing power reliability about the vital role of the transmission lines, upgrade and rehabilitation. Thank you.
Good morning, ladies and gentlemen. It's my pleasure to be here and a part of this event, and thank you everyone for joining this session. In my presentation, I will mainly highlight how Nepal's hydro potential can be utilized for a clean energy source for the South Asian region and the benefits of implementing these high performance connectors in our country. So in Nepal, we have many river basins, more than 6,000 rivers and rivulets, and all the rivers are flowing from north region to the south region. And the north, we have a very high altitude, more than 8,000 meters, whereas in south region, we have a Thorai regions, and it is around 65 meters as per the sea level. So I think this steep gradient, this variation of altitude will be a very useful for the hydropower generation in the South Asia region. And if we can manage well, these rivers can be a strong base for water and energy security in the systems. So Nepal's hydropowers will be a clean energy source for the South Asia regions, and it can convert 1/3 of the South Asia non-renewable energy consumption to the renewable consumptions, thus reducing approximately 3.5% of the total greenhouse gas emission worldwide by 2040. So Nepal is exporting power to the India, so it is contributing to reduce the carbon emissions in itself, and Nepal has a significant jump of hydropower generation from 2013 to 2023. So this is the present power status of Nepal. Nepal is a small country with 20 million populations. So the installed capacity is around 3,154 megawatt, which is about 75.5% of the total potential of the economically viable potentials. At present, the peak demand is 2,000 megawatt. The per capita consumption is 380 kilowatts, and this is the energy and the power demand forecast up to the year 2039-40. So this slide shows the different power projects in different stages of development in Nepal. So if you can see the upper position of the slides, we have 3,154 megawatt, where the contribution of the private sector is 2,000 megawatt, and then any subsidy has 493 megawatt. So in generation side, the private sectors are very actively engaging the generations. So in the under construction phase, we have a 2,950 megawatts, and the 3,550 megawatt is the total capacity. This is under construction. And if you see about the different planning phase, maybe 5,688 megawatt are in the different planning stage. So by the year 2030, we have a total capacity of 12,000 megawatt. So if we see the expected growth every year in 2023-24, we have a planning to add additional 951 megawatt. So altogether, it will be a 3,713 megawatt. In this way, every fiscal year, the additional capacity will be added. And by the year 2028-29, we have the planning to add to reach the installed capacity to 9,246 megawatt. So in the left side of the slides, if you see the energy mix of the installed capacity, we have a 61% from hydro ROR. We have a 30% from hydro PROR. It is mostly by the private sectors. And we have a hydro storage by NEA. It is a 3%. Solar, we have a 4%. Bagasse is a 6%. That means almost 99% is hydro generation, which is a clean energy generations. So if we see the import-export trends during the past 10 years, we have imported the power from the India, especially in the dry seasons, because our hydro is very low in dry periods. But at present, the hydro generation is increasing, and at present, we are exporting power to the India. So if this slide is regarding the transmission infrastructure expansion plan. So existing, we have a 5,742 circuit kilometers. including all the voltage levels from 66 kV to 400 kV. So we have a plan, a different phase of under construction. It is around 2,800 kilometers, and the plan and committed by 2030, it's around 6,700 kilometers. So altogether, it will be 15,346 kilometers by 2030. So likewise, in the substations, we have a existing 9,800 MVA capacity. The under construction, if you see, we have in different voltage levels, it is around 9,524 MVA capacity, plan and propose 15,564 MVA, and altogether by 2030, it is expected to reach to 34,000 MVA capacity. So there are different challenges in transmission and distribution constructions. Now the old lines are overloaded. That's why there is a frequent tripping of lines. The construction of new lines is a very critical in our country, because there is a very lengthy process for the land acquisition and the forest clearance approval. But there is a constant increase of demand. That's why we need to replace the existing transmission line with the high capacity performance conductors. So this is some of the projects that we have implemented, the high performance conductors, where in 66 kV and 132 kV, and the capacity has been doubled. Because of that, it makes the public safety, and it eliminates the power cuts, leading to the reduced use of DG sets and lower carbon emissions. So these are the transmission lines where this upgradation work is going on. So from serial number 1 to serial number 8, this is the upgradation work in 132 kV. The old capacity is 600 amperes, but with the implementation of the ACCC STLS, it will be 1200 amperes. It will mostly doubled. But the 3, 9, 10, and 11 is regarding the new construction of transmission line, where we have utilized the STLS conductors into 20 kV and 132 kV. I think from the previous, my friend from EGAT, they have already mentioned the benefits of utilizing this STLS conductors, so I don't want to repeat it again. So this is the one case study where we have used the STLS conductors instead of old ACR beer conductors. Before the capacity was only 100 megawatt, and there was a critical problem to supply load in especially the capital city. But after the upgradation within the 1 month period, now we can supply the required load in the capital city. This is the if we have to make a new transmission line, definitely we have to cut the 700 trees and maybe 200 acres of land we have to capture. So it is making a difficult situation for us. So this is the 400 kV infrastructure. I think my time has already finished, so I don't want to go again. This is a transmission 400 kV transmission network being constructed by the assistance of different donor partners. So this is the high capacity efficient ESB grid. That's why if we have to make the 100 kilometer 400 kV line, how many trees have to be cut and how many COT has to be emitted. That's the best example of the lines. Thank you very much.
So without delaying much, probably I will invite the final presenter, Mr. Prasad Tejram Reshme, Director Projects from Maharashtra State Electricity Distribution Company Limited. Thank you.
Good morning, everyone. Thank you, ADB, for inviting me to such a beautiful program. And thank you all for attending this program. So, my name is Prasad Reshme. I am Director Projects, Maharashtra State Electricity Distribution Company Limited, Mumbai. So, I am going to present regarding upgradation and expansion of electricity distribution grids in Maharashtra. So, with the overview of Indian power sector, here we can see that Indian demand is 243 megawatt. It is growing at the rate of 5.7 CAGR. Renewable energy contribution is 82 82 gigawatt, growing at the rate of 19.5 CAGR. So various initiatives have been taken by the government of India for improvement in the power sector, out of which revamped distribution sector scheme, which is RDSS, it is being launched, amounting to 8.4 million. Loss reduction, system strengthening and smart metering are the basic works to be covered under this scheme. Then ease of living, reliable and quality power supply to all the consumers, and improvement in the consumer services. Then third one is the emphasis on the renewable energy sector. So government of India has come up with the Kusum scheme, where Kusum A, Kusum B and Kusum C components are there. In Kusum A and Kusum B component, in Kusum A and Kusum C component, decentralized solar plants are to be established, and under Kusum B component, off-grid solar pumps are to be established. So this is the scenario of Maharashtra state power, Maharashtra state. So Maharashtra is third largest state in India. It ranks first in terms of economy, and Maharashtra's energy demand in year 24 was 207 billion units. So MSEDCL is one of the distribution company working for Maharashtra. It is the largest power distribution utility in India and probably second largest in the Asia. It serves around 30 million of consumers. In 2024, it sold 131 billion and catered to maximum demand of 25 gigawatt and generated revenue of $12,236 million. So on the right hand side, MSEDCL contracted capacity is given, where we can see that 52% thermal capacity is there, and 7% hydro, 3% nuclear, 7% other non-conventional, and total renewable source power is 35% for Maharashtra. Around 11 gigawatt solar power is contracted for the rural distribution, and MSEDCL is now focusing on the RTC, real-time clock, green energy and battery storage. This is the infrastructure details in Maharashtra, where we can see that number of consumers are 30 million. Annual sales is 1,31,000 million units. Maximum demand catered so far is 25.2 gigawatt. And total employee strength we are having is 80,000 numbers. So the infrastructure details in Maharashtra are, there are total 4,233 kV by 11 kV substations. Total distribution transformers are 8,75,000. LT lines are 6,76,000 kilometers and ST lines is 3,84,000 kilometers. The consumer mix we can see here is that 74% is the residential mix, 15% is the agriculture load, 1.5% is industrial and commercial is 7.2%. So 15% of the agriculture load consumes around 30% of the power in Maharashtra. So why there is a need to upgrade the distribution infrastructure? So presently there is a rising demand. As we all know, India to become a 10 trillion economy by 2030. So accordingly the demand will rise. Rise in per capita consumption and penetration in electric vehicles. Electric vehicles are coming in very faster way. So it is also adding to the load of power grids. Then integration of growing renewable energy in the grid. So far Maharashtra is concerned, around 17 gigawatt agriculture solarization feeder scheme is coming. Then 3 million solar rooftop consumers by 2027 are expected to come, which will add on to around 9 gigawatt of the solar power in terms of rooftop. Then there are some transmission constraints in Maharashtra. Actually, the total generation in Maharashtra is happening in the eastern part, whereas the load center is in the western part. So the transmission lines are always overloaded. Then there is a congestion in north-south corridor also, due to which renewable power flow is impossible or it is difficult. There are some distribution constraints due to aging infrastructure, high technical loss due to overloading, number of trippings, interruptions, difficulty in accommodating decentralized solar generation. Then technical advancement of power system is planned by Maharashtra state, wherein use of IoT regime for fault detection and restoration, auto reclosers, etc. And SCADA system is to be implemented for this. So how to overcome this constraints? So Maharashtra government along with MSEDCL has started the load flow analysis and network planning of the system, wherein system under overloaded condition, underloaded condition and normal load condition is studied. Explore the possibility of battery storage where solar generation is coming. Explore the possibility of reactive power compensation is done. Then system strengthening under RDSS scheme is planned for around 4.6 billion USD, wherein agriculture feeder separation around 5,000 agriculture feeders will be separated. Overloaded feeder bifurcation will be done for 1,000 numbers. New substations and upgradation for 527 new substations and 705 numbers of substations will be upgraded. Underground cabling and AB cables. High voltage distribution scheme in the loss making areas. Smart metering system metering, around 25 million smart meters are considered under this scheme. And augmentation of distribution transformer, around 26,000 distribution transformer will be erected and 16,000 distribution transformer will be augmented in the near future, and use of SCADA system in the distribution network. So MSEDCL and Maharashtra government has come up with the Mukhyamantri Saur Krishi Vahini Yojana 2.0. It is the advanced version of Kusum A and Kusum C scheme by Government of India. So Government of Maharashtra has designed this scheme in May 2023 and set the objective of around 30% of the feeder solarization by 2025 as a mission 25. With this running scheme, around 1,500,000 farmers will be benefited. 15,000 agriculture farmers will be benefited. Then the land requirement portal is there. Accordingly, land acquisition is being done. It is in process. Presently, around 9,000 gigawatt power is being contracted by MSEDCL. And for this purpose, basically in Maharashtra, the agriculture load is served in daytime and nighttime 50-50%. So with the help of this scheme, daytime power will be imparted to the farmers, and this will result in bringing all the load of the system in daytime. So accordingly, system strengthening is planned under this scheme, and for this expected expenditure is 1 billion USD. And for this, we need support from the ADB. Already PPR has been submitted, and I think it is under the process. So we are sure that in the near future, we will be able to handle this much of the solar power in our system. Thank you.
I know there are so many presentations, but we thought of giving this perspective from probably from one of the largest distribution utilities in the world to almost to the smallest microgrid, in South Asia. So that's one of the reasons why we thought, it is better to have many presentations. But without delaying much, probably I will request all the, speakers to come onto the podium to have a Q&A. Thank you. So we have 15 more minutes. So probably if there is any if there are any burning question, I will allow one first, or otherwise I will ask the questions to the panelists first. Okay. So probably I will ask the first one to probably Mr. Tosakun. So I understand basically EGAT overcome the challenges by upgrading your transmission upgrades, and and you also used the HTLS conductors. And what made EJT to choose ACCC? That's a particular choice of conductor you choose for this upgrade, right? So we just wanted to understand if the perspective of ACCC. Thank you.
Okay, thank you for your question. Actually, it depends on the project requirement. For Hinkong power plant, our requirement is a double capacity on existing tower. No need to upgrade the steel structure. No need to upgrade the tower foundation. Something like this that can affect to the community area. So if you focus on the maximum capacity of INVA conductor, it cannot meet our requirement, but for ACCC conductor can do. By the way, ECAT have not only specific on only ACCC conductor, but also we open for all kind of advanced conductor to join to our bidding process. If it meet our requirement. And by the way, I want to say something. In some area in our system, we have a problem on the high short circuit current. So if we choose if we apply the high impedance or high resistance conductor like a INVA, something like this, it can reduce our short circuit problem. Sometimes it's gonna be okay. I think it's not possible for one solution fit for all. Thank you.
Thank you, Dr. Sakun. That's so probably this specific conductor is very compatible with the proposed inward conductors, right? So that's very interesting to see. Probably similar to the question which I would like to ask. Probably I will go to the other transmission, Nepal Electricity Authority, because they have done several transmission upgrades using HTLS. And basically, as everybody in the audience may know, that the transmission losses are, of course, the loss reduction is the ultimate motive of upgrades of HTLS, but the transmission losses are also proportional to increase in current I square R. So how the transmission utility design the conductors when you use the HTLS? We also how ensure that it is not going beyond a certain values, that it will increase your losses rather than decreasing. So probably I try to get the perspective from NEA. So please.
Thank you, James. Actually, NEA has implemented more than 15 projects, 15 to 20 projects implementing the ACCC conductors. And actually, I have already mentioned in my presentation slide also how it has benefited NEA for evacuating the power to the load centers. Not only the load centers, even we have number of IPPs whose power has to be evacuated to the load centers too. And in that case, we have already taking the benefit of the implementing these STLS conductors because in the urban valley there is many issues of ROW, so we cannot construct the new lines. The only option is to upgrade the lines and evacuate more and more power to the load centers. And I have also shown in my case study also, because one line from New Khimti to Lama Sangu is a single circuit line. So because of that line, we are facing many difficulties of evacuating the power to the Kathmandu Valley, and even when there is off-peak in Kathmandu, the surplus power has to be evacuated to the pooling hub from where we can send that power to the India also. So regarding this, I think maybe 700 to 800 megawatt capacity has been added in the transmission systems overall, I can say. And regarding your loss, how the loss has been managing by the NEA after implementation of the STLS. So definitely when loss is directly related to the current. So if we limit it to a certain temperature, because also it depends on the ambient temperature too. If the loss is within, we have to limit the loss within the limits, then we have to load it to the 70% loading. and also the ambient, this ambient temperature also plays an important role. So I think we have only 255 circuit kilometers we have implemented in different projects, and our total circuit kilometers is around 6,000 circuit kilometers. So it is only a small portion that we have implemented in our systems. So there is not a major role in the loss. This loss, it will go more losses, I can say, and we are limiting the loss in our systems to 12 to 13% in our overall systems. Thank you.
Thank you, sir. Thank you. So probably now I'll go to Nicholas. Basically, so in ADB, when ADB finance projects, we also look for some innovative solutions to ask the utilities to adopt innovative solutions, and we also want to eliminate SF6 as much as possible. So that's what one of the things we would like to do. But the challenges we face is the utilities ask, oh, whether this is proven. One of the questions that will come. And the second question is, why distribution? Because SF6 is largely used in transmission in 130 to 220, 400. Can we, they ask whether, because the utilities are more comfortable if it is tested at a higher voltage, then they said, okay, we can use it now. So probably, and the second question is, if whatever system you have, what is the cost versus SF6 versus your system? So just give a perspective to the utility. I don't need the exact one. Probably you can give a ratio. Thanks.
Sure. Thank you, James. Yes, so regarding the question about functionality and whether this technology works, so these technologies go through the same certification or type testing procedures that all other switchgear technologies go through, and the technologies have passed these processes. We have initial references that have been in the grid for a number of years already, and they've worked as expected. So there's been no issues there. Often when we talk to grid operators, it seems like we're going for a job interview for an entry-level position, and one of the requirements is 30 years of experience, which with new technologies isn't really the case. Of course, we don't have the 40, 50 years experience of previous technologies. But so far, as I said, the technologies have been type tested, they've been certified, early references have been successful. Of course, the new technologies, but they've worked as expected. Regarding the pricing question, so I can only speak for my company, Ventura. I don't know about the price levels of the other companies. But yes, of course, right now it's a new technology and there's a slight premium to the technology, around about 10-15% on compared to SF6 products. But that, it has to be said, we're producing right now at relatively low volumes, and we see no reason why at higher volumes we wouldn't be competitive with SF6 switchgear.
Yeah, thank you. And also probably the operation maintenance cost, maybe, the handling SF6 and, this can be taken away later on. So,
exactly. Yeah.
So I would like to, request, now Mr. Reshme sir, basically, to about, the Maharashtra has always been one of the forefront in modernizing the grid. In earlier ADB project, you have adopted HVDS and, now considering solarization of agriculture feeders. And, you have a, massive task of integrating the renewable energy now. So, and also considering the additional rooftop solar. You from the Prime Minister's recent, PM Suryaghar Muft Bijli scheme. So, what is, what is the system planning? What is the basic, system planning you wanted to share your experience with if other utilities here, considering the massive experience Maharashtra has? Thank you.
Has come up with the ambitious scheme of Mukhyamantri Saur Krishi Vahini Yojana, wherein solarization of the feeder is considered. Around 30% of the present feeders are to be solarized, and which will result in flow of around 70 gigawatt power. At the same time, at the same time, Pradhan Mantri Suryaghar Bijli Yojana, the rooftop scheme of India, it will bring around 9 gigawatt of the power. So 17 plus 9. So 26 gigawatt of the additional power is going to come. In addition to this, some small projects are also there. So we expect that by 2030, around 30 gigawatt of the renewable energy will flow in the system, and accordingly we have designed our system. So for this purpose, we have prepared a network analysis, network plan, where this system constraint, system loading under no load condition, under full load condition is already studied. And the impact of this on the consumer services is already been worked out. And the need for system improvement is already worked out. So as I said earlier, so there are some schemes under place, the projects are going on. Presently RDS, under RDS scheme, around 5,000 feeder separation is under progress. And creation of around 500 substation scheme is already under approval to the government of India. At the same time, around $1,500, $1,500 million loan is being sought from the ADB. So the plan is under process and work is already been started. So we are hopeful that by 2028, 2029, we will be able to ready with the infrastructure in Maharashtra.
Thank you, sir. Thank you. So, Nicholas, you know whom you need to talk to, right? So,
Exactly.
the massive infrastructure development required in these states, you know. So I would now request Ms. Luza, on the, her presentation on interesting the island grids. What is the lesson and experience that you would like to share from integration of renewable energy, considering the small, mini grids in outer islands?
Thank you, James. Our experience in outer islands is that the demand is increasing significantly, especially in the islands where tourism is flourishing. And so it is difficult to plan ahead the investment and generation assets. So a good technological solution is needed. And also because of the land constraint, we need to go for other innovative solutions like floating solar and ocean-based technologies.
Thank you, Luza. So basically, Maldives in some of the smaller islands, basically the demand is only probably in the order of kilowatts. So, with a one guest house, the demand can go up to 50% or 80%. So they need to cope up with the system based on these requirements. And with that, probably I'll go to Devshi sir. Now, he already mentioned that, they are already struggling with, struggling with the consumer mix. So with the new Prime Minister's Surya Ghar Muft Bijli scheme, to be implemented, across India, which aims to provide free solar electricity to one crore households. And additionally, basically that is one thing. How the state of Tripura is going to do, because we saw the perspective from Maharashtra, which have a very large industrial base, but on the Tripura other side, which only have household base. So how they are going to take this. And finally, Tripura has an interesting scenario as well. They have a potential for power trade with Bangladesh because we're very, very close. So how you are going to converge, this and take this state forward? Thank you.
Thank you, James. As everybody knows, PM Shirega scheme is already live all over India, and every state has got a mandate to have a solar rooftop in every other residential plots. And we, as I've already told, our maximum consumers are residential consumers. We fear that most of our high-paying domestic consumers maybe opted for the solar consumers, and then our overall load will be reduced, because it cannot be subsidized by the industrial loads and other things, because industrial load is very scarcity in Tripura. So we hope that the additional powers, because it will ultimately supplement our RP obligations, because we are also short of a RP obligation. That is another one thing. We can save the penalty, and we can have a mixture of the gas-based power plant and the solar power plant, because fortunately or unfortunately, our oil depletion, gas depletion is going in very fast. For the last 1 year, we have reduced almost 100 megawatt of generation because of the low gas availability. That can be supplemented by the renewable energy, and ultimately it will have a mixture of renewable and non-renewable energy. And in the futures, we are planning for the power trading more and more to the cross borders, because we are already connected with Bangladesh. We are planning to connect with the Nepal and other things, because it was previously there was a connectivity in Nepal. As you know, to the cross-border trading, there is a trilateral trading concept is going on. So we can plan for the export of power to the outside is during the export period, during the or lean period. So that is the way we will try to tackle this issue. Thank you.
Thank you, Mr. Devashish Sarkar. And now, last but not least, I'll ask, John Cotton. He has a comprehensive presentation on smart grids and how this is supporting the ETP is supporting, the comprehensive solution. And I would like to understand from him how this has been, prepared to enhance the renewable energy penetration in the future. Considering Indonesia's ambitious targets for renewable energy, and also on distributed renewable energy. Thank you.
Yeah, so there are many challenges in incorporating variable renewable energy, and the leadership of Indonesia is setting very ambitious targets. The project I talked about was with PLN. The CEO of PLN, Badamawan, 2 years ago on the sidelines of G20. He's a very strong character. He made a very rousing speech about how PLN will embrace the energy transition and how they will drive it forward. The control center that we worked on is a piece of a much larger jigsaw. The jigsaw, inside the jigsaw, it's a real mess, but it's policy, regulation, legal, technology, innovation. The control center, though, offers the opportunity to overcome the technological barriers that we face. It reminds me, it was my daughter's birthday on Monday. We bought her a tablet. We don't really like technology. She's had to wait 10 years. Every day I've had a new request come through. Can we buy this? Can we add this to it? And just this morning, my wife sent me a message saying, did you know, John, that we can put an app on which will help me learn to play piano? Can we buy it? My response was, we don't have a piano. But this is how it's been working on the control center. Every time we go in and have these discussions, the team, which might have been apprehensive at the beginning, are reading more. They're going through capacity building. They're talking to the new equipment suppliers. Did you know we can do this? Did you know we can do this? We can do this. It's breeding an excitement. ETP has 3 programs which are also trying to support this type of mindset. One of them is called the PLN Business Center of Excellence. It's basically working with the PLN board to look at how we can create profitable business streams from the new technology, because profitability essentially is at the root of all of this. And then we have 2 projects, one on solar, 1 gigawatt of solar, and one on wind. And then together it's overcoming the puzzles that will gradually come on board. So as the solar and the wind increase, the challenges are there, but the teams are excited to take on the challenges, and hopefully I see the innovators, the private sector, the financiers are seeing the opportunities that will come with it. So we're at a time of great change, but we have to move quickly, and I think by addressing first the grid, it creates the right environment to progress.
Thank you, John. Probably I will open up again to the audience, please.
Hi, I'm Vibhanu. I represent a company called Demo in Sri Lanka, and we've been representing Siemens for last 70 years in Sri Lanka. So my question is to Nicholas. The AI is, I completely agree with you. The lowest hanging fruit would be to convert existing GIS substations or future GIS substations to AI substations, both at transmission grid level and also at primary substation levels. But this AI technology at 33 kV and 11 kV level has been there for a while. It has been there for decades, and in fact, CB, Sri Lankan Utility, has recently floated its first ever 33 kV AIS substation, and the evaluations are underway. How your technology is different from the existing technologies? That's a question. Thank you.
Sorry, the question is if our technology has taken from existing technologies?
How it is different from existing, which has been there, and how can it add value to the systems?
Yes, okay, understood, very good. So our technology is a gas-insulated switchgear. So it has the same capabilities, same advantages as traditional SF6 using gas-insulated switchgear. But the only real difference is that instead of the SF6, we use something called dry air. So in terms of the operational UX, dimensions, so all the qualities that you expect from a traditional SF6 product, we continue, but we just remove the carbon footprint. That's essentially what we offer. I hope that answers your question.
Anyone else? Okay, please.
Hello, thank you for the great presentation, everyone. I just had a quick question. Many of you guys talked about upgrading infrastructure in communities where power grids already exist. How would you go about integrating these power grids into communities that don't have any existing infrastructure, like rural and poor communities?
So who in the audience want to take this? Who in the panel want to take this? So basically, his question is how the unconnected will be connected in the upgraded or new infrastructure. Probably any of them. Devish sir, you want to take it, or probably or NEA, or it should be from one of the utilities.
Okay, thank you for the questions. I think what's his question is regarding the in the new lines, how you upgrade the STLS. That is their questions, or I think in the new lines, I think we don't have to put the STLS because while designing the load of that area, then we can use the other conductors because this conductor is little expensive and that's why I think. Whether if there is no options to make the new lines, only that in that area only we can implement the upgradation of the existing old lines with the same towers and some.
So
That's
so actually, basically when they plan the transmission network is also to support the distribution network. So basically, when they support the distribution network, they also connect the unconnected. So that's what it is now happening, because upgradation is not just for transmission, but it also indirectly supports the distribution for power evacuation. Thank you.
Thank you.
Anyone else? Okay, please. Lady first.
Hi, thank you for these presentations. My name is Jennifer Chen. I'm with the World Resources Institute. I'm wondering, so it sounds like there are a lot of different types of technologies, each with different kinds of benefits, lower line losses, better use of existing land, or just lower greenhouse gas emissions from other types of greenhouse gases. And sometimes these technologies are adopted on an ad hoc basis, but as we go forward with the energy transition, we'd like to think about how we can make this more systematic, adopting these new kinds of technologies. And I was wondering, in terms of how utilities or other types of potential entities that would take up these types of technologies, like how do you evaluate, given a certain need, how do you evaluate the technologies that you're looking at? And is there a framework that we can think of with a system of metrics or indicators that we can adopt to more systematically scale up technologies that make sense in all of these different cases? Thanks.
So who in the panel will be the right person to answer? Do you have someone to point?
Well, anybody, perhaps the utilities, how do you go about evaluating which technologies to take up when you have a
Reshma
need?
sir, you want to try? Being the largest power distribution utility in the world.
So, as you rightly said, first of all, thank you for your question. As you rightly said, loss reduction is a big challenge in the distribution utilities. So, various technologies are being used, but conductor and lines will be there. Unless and until conductor and lines will be there, no power can flow. So the technologies presently we are using in Maharashtra are smart meter technology. Earlier conventional meters we replaced by the smart meter, we are replacing it. The project is under progress. Second one is to convert the bare conductor by the aerial bunch cables and underground of the system. So these technologies are proving very lot and giving good results for reduction of the AT&C losses. So probably these three technologies we prefer in Maharashtra, in India, to be more popular.
So as you might have seen, many of these presentations come across loss reduction. loss reduction is the first step of energy transition as well. So they are always trying to achieve loss reduction by using these technologies, which is more financially and
Can I add?
Please.
Also from the this should be also prevalent from the area to area. As for our state in Tripura, if we are going for a more and more renewable energy, solar energy space is a constant. We cannot have a land-based solars. So we are planning for the floating solars. Floating solars is also not feasible as per the NTPC's feasibility study. Now we are going for the pump storage as well as the battery storage. So we have to have a mixture of renewable energy and the conventional energy, but there are some constraint in the as per the geographical position. So that is again very relevant for the overall. If you see the overall India scenario, there was a different geographical terrain, different terrain, and on the basis of this, technology varies. So we have to adapt as per the terrain availability and as per the technology availability, which is there should be a good mixture of that. Thank you.
Thank you. Thank you. Probably one last question. Oh. Anyone? Okay. No more? Okay.
This is regarding, hi, this is Mangesh. I'm from Maharashtra, India. This is regarding SF6 breaker. Devashish sir in his presentation pointed out that they are going for vacuum circuit breakers instead of SF6 because of the polluting nature of the gas. Transmission and distribution utilities being the prime focus customers for the SF6 breaker manufacturers, how will you change the perspective of the distribution and transmission utilities?
So I think it has been discussed during our this ADB's scheme implementations, because we all know the SF6 is a polluting gas, and our auto reclosers and sectionalizers are coming new. So we are consciously trying to avoid the SF6, but we cannot eliminate the entire thing because there are so many SF6 breakers in the circuit itself. We want to phase it out in the SF6 and put it by the vacuum circuit breakers. Now we have heard in the new technologies coming with the dryers, so we can think of that. And because as we have been told that SF6 we have to phase out in a phased manner because of the pollutions and other things, and as we are to contributing to the carbon neutrality, so that may be one of the contributions. So that is our planning, and because of our small nature of the network, it is possible for us to do it. It may not be possible for your MSCDCL, which is a huge network. So that also is possible.
Thank you. Any final words from the speakers before I close? Okay. Thank you all for joining us today. I wanted extend my deepest gratitude to all the esteemed panelists and also the presentations, and also to the audience for the engaged and thoughtful questions. And your presence and participation made this session very fruitful and meaningful. Thank you. Thank you, everyone.